Awesome guys, now I get it. Now what we're going to do is go through and check out a little bit of a worked example on how to sketch both quadratic and linear equations and show the points of intersection between these two lines. So let's check that out.
Alright, so as you can see, this worked example says solve the system of equations with y equals x squared plus x minus 2 and y equals 3x plus 1 and illustrate the solution using a sketch graph. Alright, so the very first step that it says all the way up here is ensure that the linear equation is in the form y equals mx plus c and the quadratic equation is in the form y equals ax squared plus bx plus c. Let's have a look at the quadratic equation first. So we've got y equals something x squared plus something x minus 2, so yes that is. And the linear equation now, we've got y equals 3x plus 1, so that's y equals mx plus c, that also is. Great, so step 1's done. Step 2, make the linear equation equal the quadratic equation. So what we need to do is write out both equations now. So we've got y is equal to x squared plus x minus 2, call that equation 1, and we've got y is equal to 3x plus 1. We'll call that equation 2. Okay, so what I'm trying to do here is I'm looking at both of them and I need to find the point of intersection between these two lines. Now to do that I need to use simultaneous equations. Now as you can see I've got the y on its own in both instances here, so I'm going to use the substitution method in order to be able to do this. So what I need to do is make the linear equation equal to the quadratic equation. So instead of writing our y here, I can write 3x plus 1. So let's go through and do that. I've got 3x plus 1 is equal to x squared plus x minus 2. Step 3 says rearrange both sides to get all terms on one side and make the other side equal to 0. So to do that I'll just subtract 1 and 3x off both sides. So 3x minus 3x, that's going to be 0. So I'll have x squared plus x, and I'll go minus 3x minus 2, and when I go 1 minus 1 that's also going to be equal to 0. So I go minus 1 here. So this side here is equal to 0. I get x squared plus x minus 3x minus 2 minus 1, which of course gets me 0 is equal to x squared. X minus 3x is negative 2x, and negative 2 minus 1 is negative 3. Step 4 says use the discriminant to tell us how many solutions, that is how many times they intercept with each other. Well, let's go through and do that. I'm going to write the discriminant is equal to b squared minus 4ac. Let's go through and label my a, my b and my c values. Now my a is the number out the front of the x squared, which happens to be 1. My b is the number out the front of the x, which happens to be negative 2. And our c is the negative 3. So we'll go through and substitute that in now. So we've got our b squared being negative 2 squared minus 4 times a being 1 times c being negative 3. Negative 2 squared is 4. Negative 4 times 1 is negative 4 times negative 3 is positive 12. So therefore I end up with an answer of 16. And because the discriminant is positive, we have two solutions. That is, both graphs will intersect with each other twice. So now that we know that we've got two solutions, what I need to do is go through and find whereabouts they actually intersect. So I'm going to use my equation that is the points of intersection equation, which is this one here that we found before, and I'm going to solve for x and then substitute in and find my y values. So I've got 0 is equal to x squared minus 2x minus 3. I need to find what x value will give me 0, so that means I need to go through and see if I can factorise first of all. Now in order to do that I need to look for factors of negative 3 that add to negative 2. Well, the factors of negative 3 are negative 3 and positive 1. Oh, wait a second, negative 3 plus 1 is equal to negative 2. Great. So what I now need to do is I go 0 is equal to x minus 3 and x plus 1. So now I can go through and solve for x by making each mini equation equal to 0. So I go x minus 3 is equal to 0 or x plus 1 is equal to 0. Therefore x is equal to 3 or x is equal to negative 1. Excellent. I've now found my x coordinates of the points of intersection, but I still don't know my y. That is, I know that it's intersecting at 3 something and negative 1 something, but I don't know what my y coordinates are. Now how do I find my y coordinates? Well, I can substitute either into equation 1, that is this one up here, or equation 2, that is this one here. Now the easiest one to do is substitute in equation 2 because we don't have to go through and square things. We only need to substitute in once and it's nice and easy. So let's go through and do that. We're going to go y is equal to 3x plus 1, and let's find out our coordinate when x is equal to 3 first of all. So we'll go y is equal to 3 times 3 plus 1, which gets us y is equal to 3 times 3 is 9 plus 1 is 10. So the coordinate happens to be 3, 10, as you can see here. Let's now find out what y is equal to when x is equal to negative 1. So go y is equal to 3x plus 1. Substituting in negative 1 now, so you go y is equal to 3 times negative 1 plus 1. That gives us y is equal to 3 times negative 1 is negative 3, plus 1 is negative 2. So our y coordinate when x is equal to negative 1 is negative 2. Excellent. Now I've found out my points of intersection, I can go through and plot those out. So I've got the coordinates 3, 10. So I come up to 3, 10. and I've got the coordinates -1, -2. So go -1, -2 like that. And I may as well write in the coordinates here as well, 3, 10, and -1, -2. Now what I need to do is go through and find out the points of interest for both equations. Now to do that, what I need to do is just, as I've done before with finding x and y intercepts for both quadratic and linear equations, I need to go through and make the other one equal to 0. So let's go through and do that. We'll find the linear equation first. So for linear equation, let's find our y-intercept first. So we go y-int, x is equal to 0, and we've got y is equal to 3x plus 1, and we make x equal to 0, so we get y is equal to 3 times 0 plus 1, which gives us y is equal to 1. So this gives us the coordinate 0, 1. And we'll go through and we'll plot that. Now we'll do the linear equation in a different colour, just to make it stand out. So we'll have linear equation y is equal to 1, 0, 1. So we're going to go here and we'll do all of our red dots for our linear equations. We'll just write 0, 1 here like that. Now we need to find our x-intercept. So to find our x-intercept, I make y equal to 0. Go through and do that now. So I've got y is equal to 3x plus 1. Therefore, when I make y equal to 0, I get 0 is equal to 3x plus 1. For solving for x now, I go -1 is equal to 3x, and I get x is equal to -1 over 3. So my coordinate now is at the point -1 over 3, 0. So -1/3 happens to be around about here. And I'll write that in now, of course, as well. So I got -1/3, comma 0. Just going to scroll down now so that we can do the rest of our working out. So what I now need to do is I have to go through and find all the points of interest for my quadratic equation. So to do that, let's just write out the quadratic equation once again. So I've got y is equal to x squared plus x minus 2. So to go through and do that now, let's find my y-intercept. And to do that, I need to make x equal to 0. So I go y is equal to 0 squared plus 0 minus 2, which of course gives me the coordinate y is equal to -2. And the coordinate for that is 0, -2. So let's come down here and plot that, and we'll do that in a green colour. So we go 0, -2, bang, right there, 0, -2. And let's go through and find my x-intercepts now. So to find the x-intercepts, I make my y equal to 0. So I end up getting 0 is equal to x squared plus x minus 2. Wait a second, I've got two different types of x, so that means I need to look to factorise first. So what are the factors of -2 that add to 1? Well, I've got x and x, -2 that add to 1, so I've got +2 and -1 will get us 1, so I end up getting 0 is equal to x plus 2 and x minus 1. Therefore, when I solve each mini equation, I get x plus 2 is equal to 0 and x minus 1 equals 0. Solving for that now, I get x is equal to -2 and x is equal to 1. This will give us the coordinates -2, 0 and 1, 0. So I'll go through and plot those now in my green pen. So -2, 0, bang, right here like that, and 1, 0. It's right over here like this. Now as you can see, there's lots going on. And the very last thing I need to find whenever sketching quadratics is of course the turning point. So to find the turning point, I need to use the formula -b over 2a, comma, c minus b squared over 4a. Now let's go through and write out the equation of my quadratic once again. So I get y is equal to x squared plus x minus 2, where my a is equal to 1, my b is equal to 1, and my c is equal to -2. So substituting in now, I've got turning point is equal to -b is 1 over 2 times a is 1, comma, c is -2, minus b squared being 1 squared, over 4 times a being 1. This ends up getting us -1 over 2, so -1/2, and -2 minus 1 squared is 1 over 4 times 1 is 4, so minus 1/4, which will get us -1/2 and -2 and 1/4. So I now come down and plot that in. Of course, once again, I'm using my green pen for the quadratic, so I go -1/2 down here, -2 and 1/4, which will be around about here, and now I can go through and sketch each graph. Now I may as well sketch the graph of my green one, being my quadratic first, because I've got my green pen out. So I'll go through and do that. It's got to go up through here like so, and it's got to go through the y-axis there, up through the x-axis, up through where they'll both intersect together, like that. Now if I'm going to sketch my linear equation, what I need to do is grab my red pen, because that's what I've been using for my linear equation, and I'm going to join the dots here between all of them. So it goes through the point of intersection that we found, through the x and y ints, and up through the point of intersection that you found here. And there you go. What we've done is we've sketched a quadratic function that you can see here by the green one. we'll sketch the linear function that you can see on the red one, and we've shown the quadratic x-intercepts and the y-intercept and the turning point, the linear x and y-intercept, and also we've shown these points of intersection that we originally found right here and here by making each equation equal to each other. And of course I found my turning point